Welcome everybody. My name is Arnold. As just said, I'm the founder of Nebul. We are a Dutch cloud service provider that focuses on AI, delivering sovereign AI within Europe on European values on privacy, security, and compliance. I want to talk to you a little bit about what we do, right? Sorry. So AI got a lot of attention, and what you see right now is that lots of companies are trying to go into the AI space and find out that it's more than just using the Azure AIs or OpenAI. It's basically using a full stack, and you need to have full control over your GPUs, your software layers, and your applications at the end. And that's what we are all about. Just testing the audience. Who's working on AI at this moment? Who is running a project? Quite some. And are you running those projects in your own data centers, or are you using public cloud services for that? Public cloud? Hands for public cloud? Okay, lots, 50-50. So what we always say to our customers is, if you use those public cloud services, you're basically bringing your data to the AI instead of bringing the AI to your data. So that's one very important consideration to make. And why is this important? Because while AI is very good, and we think public AI like OpenAI is also a very good platform to use, but it's a platform basically to get acquainted with what AI can do, what the promise is, and how you can work with it. So it's to learn and experiment. As soon as you want real answers from an AI and real quality from an AI with high accuracy, it's essential that you connect your corporate data to that AI. We all know, everybody here has been on ChatGPT, I guess, and we all know that ChatGPT can answer with a high amount of certainty that the specific question you asked, it will give you a false answer, what you know is a false answer, but it's very certain about that it's giving you the right answer. We call this hallucination, and that's because this is the cause of hallucination is that the model statistically thinks it gives you the right answer, but well, in practice it's wrong. So for AI to be successful, we need to really amp up the quality of the accuracy of AI models, and we do that by connecting AI to your corporate data. So as soon as we start connecting data to AI, privacy becomes essential, right? Lots of companies have IP, patient data, essential sensitive data. You cannot connect that to a public AI without fully understanding the risks. So we've solved it by delivering a full stack end-to-end AI solution that delivers not only the software layers, as said, and the data layers, but also the GPUs and everything around it as a full package. With, in the end, European compliance as a result. Also, it's already very important, but it will become much more important if you look at the world today, what's happening. The amount of legislation we see will basically increase, not decrease. So having that compliance behind you is major important. What we do to make sure that our customers get the most value from our AI stack is that we build applications for vertical industries. So same here, if you go to ChatGPT or Azure AI, you will see a platform that's basically built for generic use. And we think that AI becomes much more powerful if you convert it to an industry vertical solution. That means that you make sure that you have industry-specific prompting. So the prompt knows what your company is about, it knows the jargon, It can answer questions much more specifically. We've got predefined assistants. Those assistants are already set for a specific task, for instance, writing a contract or answering questions, doing Q&A, all with the specific data in your data sets from your company. And then in the end, mining that data that we all have and taking real value from that with an AI, you can use solutions like hybrid search. That's AI-powered search to delve to those enormous data vaults. Models make the difference. So we all know the models like OpenAI uses, right? GPT-4 and the reasoning model, DeepSeek, for instance, that's coming out. What we will see is that we will get basically the set of models that you see behind you. So most of us will begin with a foundational model, which is basically pretty standard. And we will work towards more specialized models for specialized jobs. If you look at it like that, it's basically a mirror of your company, right? You don't have one person working there. You won't have one AI. You will see different AI models for different jobs. Some are very big, some are small. But if we look at the future, we think it will be lots of small models, very specialized for a specific task, with a model in front of it to rule them all, right? Basically, if you look at GPT today, you already see that happening. If you ask a question, it will send you to a model on the back end. You don't see it as an end user, but there are different models working on the back answering your question. The technology stack we use. So this is more interesting, I guess, for the more technical people. So on the top, you will see the GPTs and the factory. The GPT is about consuming your AI. The private AI factory is about training and tuning your AI. That's where I would say 95% of the AI spend is currently taking place, right? We're just building, training, tuning models and applications. As soon as we get that to a certain point of maturity, and we've got applications that really work well, we will convert it to inference. And that's something that you see kicking off today, as in converting those models that have been trained into really workable solutions for businesses. Beneath those two application layers, you'll see the models, from foundational models to industry-specific models to tailored models. So for companies that want a very specific model for their own, this is something that's also happening quite significantly. And I would say if right, the things that make your business look different today, if you want to convert that into business differentiation tomorrow, you will also need an AI that does that. If you all use the same platform, you will blend into a light form of gray. So AI will be differentiating. You will need differentiated AI to be successful on that step. In the middle, you'll find platform services. Platform services are basically the real complexity, getting that all to work with the technology, the applications, getting it work with the platform below, the GPUs, the compute, the specific networks. If you look at an AI platform, you would think it's just a server with some GPUs. I can tell you it's not. It's really much more complicated. We use different networks. We use InfiniBand instead of Ethernet. We use NVLink. We use those networks to create large clusters of GPUs. So 10, 20, 100,000 GPUs working as one on a single model. And getting that to work within the Kubernetes stack is pretty complex. So Challenges we faced. Biggest problem we had is basically getting the technology stack up and running. We started with that 3 years ago. All the technology there is a single tenant. So if you talk to NVIDIA, they will tell you that AI is being used by an enterprise with a single tenant. And the complexity we have, we're from Holland. So for us, an enterprise is everything north of 1,000 employees. So from American standards, that's very small. But we need to be efficient. We need to put multiple tenants on a single cluster. And Kubernetes, by design, is not multi-tenant anyway, not military-grade multi-tenant. So it's not working very well. Was not working very well for us. So, but we, as an answer to that, we deployed Kubernetes clusters per customer. And that meant in the end that we were running lots and lots of Kubernetes clusters, all in a complexity of making sure the GPU and the network operators were running well. Different sets of hardware, what means a lot of sprawl in terms of drivers and lifecycle management. So for us, the question was, can we do this smarter? Can we do this more efficiently? And that's when we turned to our partner, Mirantis, and we said, Shaun, can you help us out? We need to do lots and lots of stuff on Kubernetes with the complexity of NVIDIA and the application sets. And then he introduced us to Cordant. Yeah. So,
thank you.
Thank you.
So reaching off where Arnold has spoken about some of the challenges he was dealing with in getting this environment, and a lot of this will be recognized by many of you. It's the same challenge we have inside the enterprise environments, and it's basically a platform engineering problem. And as we move forward, many of these are the challenges that you'll recognize having dealt with, I'm sure, in your own environments. You know, slow developer onboarding, developers don't want to learn new systems. In Arnold's case, with the workloads that he was dealing with, many times all that they wanted to do, especially in the inference space, is just run a model. To do that, they didn't want to have a whole separate Kubernetes cluster that they had to manage or deal with. And when you start building multimodal models or agentic style models where you're using a lot of different models to achieve your end results, there's a whole infrastructure that has to grow and scale underneath that to provide that in a stable way. That leads to massive complexity in the configuration layer. And so what we were looking at was, how do we meet these demands? How do we come up with a solution that we can give to both customers like Arnold with CSPs, partners, so we can provide them the tools for them to offer military grade, as he calls it, isolation, which becomes critical in an environment that's focused on, servicing customers, especially in the sovereign IT space, where you're coming along with data that has to remain separated, and we need to ensure that somebody isn't going to be able to break through those systems and get access to another customer's data. The same goes for just general security within a standard enterprise. You need to know that a compromise in one place isn't going to affect another. We need to have simplicity, because the more complex the system, the more people who touch the system, the greater the chance of something going wrong. We hear stories all the time about, we were upgrading a Kubernetes cluster and somebody shut down 2 of the controllers or 3 of the controllers by mistake, and it took time for that cluster to come back online. We need to find ways to avoid that and visibility and control of those systems in a secure way. So what have we been doing? We looked at how do we increase the operations, how do we simplify operations? And you'll see as we talk about this, and I've spoken about, in fact, here previously, one of the easiest ways to manage operational challenges within an environment is reduce the blast radius. Not have your traditional Kubernetes cluster idea where we have one cluster, we carve it up by namespaces, put a bunch of apps on it. If I can reduce the blast radius, I can do maintenance more easily, because I only have to engage with one person to do maintenance, or one consumer, not 10, 20, 30 consumers. Speed is a critical component of achieving any of these. If it's going to take me 3 weeks to spin up a new cluster, if Arnold has a customer come on board and he says to them, it's going to take me 4 to 6 weeks whilst I'm waiting for the NVIDIA hardware to arrive to get a cluster up and running for you, and that customer's going somewhere else. There's competition in the space. The same internally. If you go to an internal user and you say to them, it's 4 to 6 weeks to give you a new Kubernetes cluster, even if it's 4 to 5 days, they're going to Amazon, they're going to Google, they're going somewhere else, and suddenly you've got shadow IT in your environments. The other big thing is resources. Resources are not just about the resources that you're able to service within your own environment, but it's when I need to burst, when I need to create a Kubernetes cluster that's going to be able to leverage a GPU resource that's available somewhere else. And this becomes a requirement that we're seeing more and more often. Go today to Amazon and try and get EC2 nodes with GPUs big enough to do any real work. You'll be put on a waiting list. You can't get it. It's just not available. So what if I have a workload that I need today? How do I burst into those workloads? How do I reorganize an environment to give access to resources dynamically? Regionality is a huge problem. We've spoken about that. The whole reason that Nebul exists is because of regionality. The sovereign IT movement is all about regionality. And that regionality needs to be controlled both at the data layer, but at the infrastructure layer as well, to make sure that we don't get data leakage sliding around our networks. And it should go without saying, but resilience is a requirement. I can't deal with things like if I lose a node that it's going to take a few days for my next node, my replacement node to come back up. Kubernetes gives us a lot of that. We have to make sure the environments are prepared for that. So these were the problems that we're trying to solve for. So what is the solution? So we launched a product. We started working on this. This is the second generation of our multi-cluster management tooling layer. We've called it Cordant. It's a fully open source platform. And riffing off Arnold's business motto, infrastructure on your terms. How do we create infrastructure in a dynamic way to provide it for you? So infrastructure is complex. We're dealing more and more and more with many different API layers. And we need to consolidate all of those. And if we take the basic premise that Kubernetes, well, the slide doesn't build out, but okay, that Kubernetes is stable enough now and is the common base layer that runs absolutely everywhere. Name a system that Kubernetes doesn't work on. I mean, I've actually seen it running on IBM mainframes now. So if I can run Kubernetes everywhere, what's the problem? Well, I've got to manage Kubernetes. So that maturity of Kubernetes is giving me an ability to create a common control plane. And this is what we're doing here. We're saying, using Kubernetes, has Kubernetes as, to use a very twisted term here, the OS of the future. We create a flat layer of Kubernetes across all of the infrastructure we have and are able to manage that. That control plane gives me control points. Control points allow me to start to create this automation around the delivery of these environments. So we're controlling and managing the infrastructure by putting a Kubernetes layer down everywhere. We're doing that in as automated a way as absolutely possible. Now, we're leveraging all those APIs. We're leveraging the standards built within the Kubernetes community. How many of you have heard of CAPI? Very few. CAPI is the cluster API. Cluster API is a community project where all of these dissimilar vendors, the AWSs, the Azures, VMware, are all contributing essentially a plug-in driver that allows you to control these underlying infrastructures. Now suddenly we've got a control point. Those of you who've put your hand up who have heard of CAPI, how many of you have actually deployed an instrumented CAPI? And the pain is real. This is our second attempt at a offering with CAPI underneath the hood. This time we're sticking to it fully open source. Believe me, the pain is real. So what we've done is we've taken a different approach to this. We've taken an approach that if the Kubernetes fabric is the way forward, if we've taken the approach that clusters, not namespaces, are the future, Open standards and open APIs are the only way we can do this moving forward. Because if we have closed APIs, we create another layer of lock-in. And I'm going to say Broadcom, because you've all heard that problem. We want to avoid these lock-ins. We need to be infrastructure agnostic. This is critical. Just in Arnold's environment, he has multiple generations of NVIDIA hardware clusters. Each of them is unique and slightly different. He's also got an OpenStack environment and Kubernetes bare metal environments and some other legacies, which we won't mention. All of those systems we need to put clusters down on for the end user. Now, expand that out larger. Suddenly, we've got this sprawl we have to manage. We want to get away from that. That brings me to a declarative approach. GitOps is there as a secondary point. Declarative is what Kubernetes brings. What does my environment need to look like, and am I constantly moving to that state, and can I see the difference? But we've talked a lot about Kubernetes clusters here. Kubernetes on its own is basically a glorified scheduler. Now, let's just be honest with ourselves. It's a very powerful scheduler, but it's a scheduler. Kubernetes becomes useful when we start layering on services. And so what we said is for these environments, for these deployments, we look at this differently. We say the services that are required, those platform engineering services that are required to make Kubernetes useful are essentially the beachhead services. Those are the CNIs, the security setups, the configuration of Kubernetes, the CSIs, everything that's needed to be there and configured in a standard way before I can actually put a working application on it. This is critical for the future, and this is a major part of the architecture. And this was the second thing that we solved for as we were looking forward to how do we solve this larger problem. So with Cordant, we had to solve repeatability. And I'll skip over the Cordant slide for now. So the core tenet of what we're doing here is building a templating model that allows you to build up a standard template that's repeatable within Kubernetes. So we're leveraging the Kubernetes CRD environment, and this is important because now that's my record of what my environment should look like, and I can track any changes to that environment. By having a template which is unique to my environment or my environments, I can now create repeatable clusters through a simple creation of a standard CR object with minimal information and stamp out repeatable clusters. So I do the work of ensuring the configuration, the security, the setup once, and then just repeat it. But using Kubernetes standards, Kubernetes norms. The same goes for the service layer. Now, the interesting thing about the service layer is very often I want the same service components across 10, 20, 30 Kubernetes clusters. I can now provide that same service model across all of those layers. So Cordant provides us visibility, management tooling, and I'm rushing because the clock is climbing down and blinking at me. This is how we're enabling what we're calling open intelligence within the infrastructure, all in an open source tool set, and it's what we believe is the future of intelligent operations. So AI is rewriting the way we're going to do business. I'll mention this earlier, but let me tell you, traditional logic-based applications are going to go away. We're going to be running hundreds of small and large ML models that are chained to achieve our business goals. We have to have the infrastructure ready for that, and this is how we're hoping to take the future of that. Thank you. We've got 30 seconds for questions.
Yeah.